Welcome to Big Data Analytics, Technique and Tools. Module 1, Introduction to Big Data. What is Big Data Analytics? Data analytics is a science that analyzes raw data in order to draw conclusions about that information. Many data analytics techniques and processes have been automated into mechanical processes and algorithms that operate with raw data and are intended for human use. Big data analytics examines large amounts of data to uncover hidden patterns, correlations, and other insights. With today's technology, it's possible to analyze your data and get answers from it almost immediately. Big data is often described as extremely large data sets that have grown beyond the ability to manage and analyze them with traditional data processing tools. The concept of big data has been around for years. Most organizations now understand that if they capture all the data that streams into their businesses, they can apply analytics and get significant value from it. But even in the 1950s, decades before anyone uttered the term big data, businesses were using basic analytics, that is essentially numbers in a spreadsheet that were manually examined to uncover insights and trends. Big data defines a situation in which data sets have grown to such enormous sizes that conventional information technologies can no longer effectively handle either the size of the dataset or the scale and growth of the dataset. In other words, the dataset has grown so large that it is difficult to manage and even harder to garner value out of it. The primary difficulties are the acquisition, storage, searching, sharing analytics, and visualization of data. There is much more to be said about what big data actually is. The concept has evolved to include not only the size of the data set, but also the processes involved in leveraging the data. Big data has even become synonymous with other business concepts, such as business intelligence, analytics, and data mining. The arrival of analytics. As analytics and research were applied to large data sets, scientists came to the conclusion that more is better. In the business world, big data is all about opportunity. In this case, more data, more analysis, and more results. Researchers started to incorporate related data sets, unstructured data, archival data, and real-time data into the process, which in turn gave birth to what we now call big data. According to IBM, every day we create 2.5 quintillion bytes of data, so much that 90% of the data in the world today has been created in the last 2 years. These data come from everywhere. Sensors used to gather climate information, posts to social media sites, digital pictures and videos posted online, transaction records of online purchases, and cell phone GPS signal, to name just a few. That is the catalyst for big data, along with the more important fact that all of this data have intrinsic value that can be extrapolated using analytics, algorithms, and other techniques. 4 dimensions of data. We have the volume, velocity, variety, and veracity. Volume. Big data comes in one size, and that is large. Enterprises are awash with data, easily amassing terabytes and even petabytes of information. Velocity. often time sensitive. Big data must be used as it is streaming into the enterprise in order to maximize its value to the business. But it must also still be available from the archival source as well. Variety. Big data extends beyond structured data to include unstructured data of all varieties. That is in terms of text, audio, video, click streams, log files, and more. Veracity. The massive amounts of data collected for big data purposes can lead to statistical errors and misinterpretation of the collected information. Purity of the information is critical for value. These 4 V's of big data lay out the path to analytics, which each having intrinsic value in the process of discovering the value. Big data analysis categories. So we have the traditional business intelligence, the data mining, statistical applications, predictive analysis, and data modeling. The complexity of big data does not end with just 4 dimensions. There are other factors at work as well. The processes that big data drives. These processes are a conglomeration of technologies and analytics that are used to define the value of data sources, which translates to actionable elements that move businesses forward. Many of those technologies or concepts are not new, but have come to fall under the umbrella of big data. Best defined as analysis categories, these technologies and concepts include the following. Traditional business intelligence. This consists of a broad category of applications and technologies for gathering, storing, analyzing, and providing access to data. BI delivers actionable information, which helps enterprise users make better business decisions using fact-based support systems. BI works by using an in-depth analysis of detailed business data provided by databases, application data, and other tangible data sources. In some circles, BI can provide historical, current, and predictive views of business operations. Data mining. This is a process in which data are analyzed from different perspectives and then turned into summary data that are deemed useful. Data mining is normally used with data at rest or with archival data. Data mining techniques focus on modeling and knowledge discovery for predictive rather than purely descriptive purposes. An ideal process for uncovering new patterns from large datasets. Statistical applications. These look at data using algorithms based on statistical principles and normally concentrate on datasets related to polls, census, and other static datasets. Statistical applications ideally deliver sample observations that can be used to study populated datasets for the purpose of estimating, testing, and predictive analysis. Empirical data, such as surveys and experimental reporting, are the primary sources for analyzable information. Predictive analysis. This is a subset of statistical applications in which datasets are examined to come up with predictions based on trends and information gleaned from databases. Predictive analysis tends to be big in the financial and scientific worlds where trending tends to drive predictions once external elements are added to the dataset. One of the main goals of predictive analysis is to identify the risks and opportunities for business processes, markets, and manufacturing. Data modeling. This is a conceptual application of analytics in which multiple what-if scenarios can be applied via algorithms to multiple datasets. Ideally, the modeled information changes based on the information made available to the algorithms, which then provide insight to the effects of the change on the datasets. Data modeling works hand in hand with data visualization, in which uncovering information can help with a particular business endeavor. Data categories. So we have structured data, semi-structured data, and unstructured data. Structured data are normally found in traditional databases. We have the SQL, where data are organized into tables based on defined business rules. Structured data usually prove to be the easiest type of data to work with, simply because the data are defined and indexed, making access and filtering easier. Unstructured data, in contrast, normally have no BI behind them. Unstructured data are not organized into tables and cannot be natively used by applications or interpreted by a database. A good example of unstructured data would be a collection of binary image files. Semi-structured data fall between unstructured and structured data. Semi-structured data do not have a formal structure like a database with tables and relationships. However, unlike unstructured data, semi-structured data have tags or other markers to separate the elements and provide a hierarchy of records and fields, which define the data. Dealing with the nuances of big data. Dealing with different types of data is converging. Transformation capabilities of processes are being strained by the complexity and volume of the data. Big data and the execution of the related analytics are still in a state of flux. Dealing with different types of data is converging, thanks to utilities and applications that can process the datasets using standard XML formats and industry-specific XML data standards. These XML technologies are expanding the types of data that can be handled by big data analytics and integration tools. Yet, the transformation capabilities of these processes are still being strained by the complexity and volume of the data, leading to a mismatch between the existing transformation capabilities and the emerging needs. The definition of big data and the execution of the related analytics are still in a state of flux. The tools, technologies, and procedures continue to evolve. Yet, this situation does not mean that those who seek value from large data sets should wait. Big data is far too important to business processes to take a wait-and-see approach. Big data open source tool. We have the Hadoop. Hadoop is an open source software framework for storing data and running applications on clusters of commodity hardware. It provides massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. Hadoop is an open source project that offers a platform to work with big data. Although Hadoop has been around for some time, more and more businesses are just now starting to leverage its capabilities. The Hadoop platform is designed to solve problems caused by massive amounts of data. especially data that contains a mixture of complex structured and unstructured data, which does not lend itself well to being placed in tables. Hadoop works well in situations that require the support of analytics that are deep and computationally extensive, like clustering and targeting.